What up, Alex?
All right.
What up?
So what we're saying here is we went from 15 squared plus 15 to 16 squared plus 16. So if this was k squared plus k, now it's k plus 1 squared plus k plus 1. So at the end of the day, this is what we're expecting to get when we're done with the proof. All right, so let's see. First, we have to prove that n equals 1 case. If n equals 1, then we're only adding one number, and that's 2. And now let's see if that equals to n squared plus n.
Yes.
Does 2 equal to 2? It does. And that's the first step. The second step is if n is equal to k.
Wait, this one. Oh, because n is 1. That's why it's 1, not 2.
Yes. If n is equal to k, then I'm just going to have to copy this down here, switch all the n's to k's. 2 plus 4 plus 6 plus 2k is equal to k squared plus k. And that's exactly what we did there. N equals 5 gave us that. N equals 15, that was some random number I chose in the list, and it gave us that. Now I'm going to do the very next one, the k plus 1 case. Okay? And that eliminates now the possibility that you just got lucky by choosing n equals k. Okay? So n equals k plus 1. Don't you love this stuff? So this is 2 plus 4 plus 6 plus 2k plus, now we're going to add the next term, 2 times k plus 1. Okay?
Do we do, for the 2k, do we do 2k plus 1, or is it just 2k plus 2?
All right, now this is going to equal k squared plus k, and just like we did for the previous case, we're going to add the new term here, basically balancing the equation. Okay, so let's see what we have here. 2 plus, I'm not going to change this right now, but I need to copy it over. Is equal to k squared plus k plus 2k plus 2. Okay? What I'm going to do, and the way that you will know how to do it, is because you now saw me doing it. So now you have one more trick under your belt. No. Here's what we're going to do now. I'm going to just swap the places of these two. Why? You'll see why. Okay? Now, here's another trick that, again, the only way you will have known to do it is because I just showed you that that's one possibility. So, you take the 2. What's 2 made of? 1 plus 1. Okay? So I'm going to rewrite this as k squared plus 2k plus 1, right, with one of these, plus what's left now? K plus 1. Okay? It's an odd thing to do, but that's what we do. Okay. Now, what happens to this? K plus 1 squared. Plus k plus 1. And guess what? That's exactly what we had to get. Okay? So this is equal to 2 plus 4 plus 6 plus 2k plus 2k minus 1, plus 1 equals to that. So because we got exactly what we were expecting to get, that means we're done with the proof.
Wait, do we have to write like EQ?
You don't have to write that.
How do we know that we were...
Okay, so in this problem it says prove 6 to the n minus 1 is divisible by 5. Let's just think about what it means to be divisible by 5. Okay? What are the numbers that are divisible by 5? 5 is divisible by 5. What's the next one? 10. 15. So basically it's all the numbers that have 5 as a factor. Okay? Meaning if I do 5x, would that be divisible by 5?
Yeah.
It would be, because it's 5 times something. So all the numbers that are divisible by 5 look like this. Okay, they have 5 as a factor built in. Okay? Let's see where we're going to get here. Okay, so n equals 1, the first case, 6 to the power of 1 minus 1. What does that equal to?
5.
5. Is that divisible by 5?
Yes.
Yes, that's divisible. So we just proved that the n equals 1 case is divisible by 5. Now, in this problem, next we're going to do n equals k. So that means 6 to the power of k minus 1 is divisible by 5. Okay? Another way to write that, because we want to turn this into an equation that we can manipulate, another way to write that is 6 to the power of k minus 1 is equal to 5r. Just like I wrote here, if it's divisible by 5, that means it equals to some number that looks like 5r. Okay? Now, the way to solve this, the way to keep going after this step when we're proving divisibility, it's always the same process. So what you do is you say, all right, you solve for 6 to the power of k. It equals 5r plus 1. Okay? So this is the n equals k step. In these cases, the n equals k and k plus 1 steps sort of morph into one another. Okay? So the next step here is going to be this. What we're going to do is we're going to multiply both sides here by 6. All right, what's the exponent of the 6 here? Of the green 6? 1. So this then will be 6 to the power of k plus 1. Right? And you see how this now became the k plus 1 step? It equals to 30r plus 6. So this is now your n equals k plus 1 step. Okay, if you like to differentiate.
I have a question. How is 6 times 6k equal to...
6 times 6 to the k, there is an exponent of 1 here. When you're multiplying bases, you add the exponents. When you're multiplying powers, you add the exponents, same base. Okay? If you have 2 to the x, and then...
Plus like 2 to the y, it's 2 to the
x plus y, right. Now, what we need to do is we need to get this to look like this. You see how here there is something to the power minus 1? That's what we need to get that to look like. So what I do now, 6 to the power of k plus 1. Okay, so this is a lot of, okay, let me just add a number here. Let me just divide by a number here. What would I do to this to make it look like this? Minus 1, right? I can do that. But if I did that, what else do I have to do to keep it balanced?
Minus 1 on the other side.
Minus 1 on the other side as well. So now what I have is 6 to the power of k plus 1 minus 1 is equal to 30r plus 5. Now, I can factor out a 5 there. right? And look, I'm done. Because the k plus 1 step is now equal to 5 times some number. And we know that if it's 5 times a number, then that's automatically divisible by 5, right? So that's enough for me to prove that this is divisible by 5. Okay? So this factor this factor 5 is enough to tell me that my result is an answer that's divisible by 5. And that's it. I've just proved it. Okay? I proved it for the k step and now for the k plus 1 step. Any questions? Okay. Now, what I'm going to do, so this factor of 5 means divisible by 5. So my proof is now done. Okay? What I'm going to do is stop here, continue the next two tomorrow. However, I'm going to modify your homework to include some other numbers. So it's still going to be on page 615. Oh no. All right, so your revised homework is page 625, numbers 1, 3, 7, 13, and 15. Okay, 5 total problems. And the rest we will cover next class.
Can we do all